let's now look at question 8. So this is now probability, right? Let's read the question, see what it says. A bag contains 6 red balls, 8 green balls, and an unknown number of yellow balls. The probability of randomly choosing a green ball from the bag is 25%. Show that there are 32 balls in the bag. Okay? So how are we going to do that then? Well, the probability of choosing, what was it? Green. So probability of green is 25%. Okay, and what is the probability of green? Well, it's 8 over the total number. Okay, so 8 over, let's just call it t, equals to 0.25. Right, so now it's just a simple case of solving for t. So I'll multiply t to that side and then divide both sides by 0.25. Okay, so 8 divided by 0.25 is 32. So that means that there are 32 balls. So that answer is correct. Okay, 8.2. A ball is drawn from the bag, the color is recorded, and it is not returned to the bag. Thereafter, another ball is drawn from the bag, the color is recorded, and it is also not returned to the bag. Draw a tree diagram to represent all the possible ways in which the two balls could have been drawn from the bag. Show the probability associated with each branch as well as the outcomes. Okay, so let's think about this, right? When I initially start, I have 3 options, right? Well, there's 3 outcomes that could happen, let's say rather. I can either draw a red or green or yellow. Okay, so red, green or yellow. Okay, now the probability of drawing red is 6 over 32, right? Because there's 6 red balls and there's 32 in total. The probability of drawing green is 0.25, so it's 8 over 32, right? 8 over 32. Okay. And then the probability of drawing yellow is, let's calculate how many yellow balls there are. So we have 6 plus 8, which is the red and green, and that gives us 14. And then 32 minus 14 is 18, because there was an unknown number, but now we know that number is 18. Okay, so 18 over 32. Now, let's say you pick one of these. Now what's going to happen? Let's see. So let's say you pick red. Okay. In my next pick now, there's 3 things that can happen again. Right? I can either get red again, or green, or yellow. Okay. I'm just going to copy this and put it for the rest of those as well. So okay. Now let's think about this. How did the probability change? Well, initially my probability for getting red was 6 over 32. But what happened? I picked a ball, right? And it wasn't returned to the bag. Okay, so if I picked red initially, now there's going to be 1 less red. So the probability of me getting red is now 5 over 31. Okay, because there's 1 ball less in the bag. Okay, my probability of getting green is still 8, because there's still 8 green balls, but now it's over 31. Okay, and then for yellow it's the same, 18 over 31. Okay, now let's say I picked green first. Okay, now my probability of getting red is still my initial probability of getting the initial number of red balls, which is 6. Okay, so 6 over 31. And then green, now it's 1 less, so now it's 7 over 31. My yellow, that hasn't changed, still 18 over 31. Now let's say I picked yellow first. So now there's still the same number of red balls, so it's still 6 over, but now it's 31. Okay. My green, again, nothing changed, so it's still 8, but now it's over 31. Yellow, now it's 1 less, so 17 over 31. Okay, cool. So let's just read what the question said. Draw a tree diagram to represent all the probabilities. Show the probabilities associated with each branch. Okay, so the probability associated with each branch is literally what we've shown on this. Okay, let's just put what the two outcomes are for each one. So here I can have red and red. This is red and green. Red and yellow. This is green and red. Green and green. And green and yellow. Okay. This is now yellow and red, yellow and green, and yellow and yellow. Okay. 8.3. Calculate the probability that the two balls drawn from the bag will have the same color. Okay. So the probability of that happening, let's see, right? The probability of me getting red and red, and or green and green, or yellow and yellow, right? I'm gonna have to find the probability of this, the probability of that, and the probability of that, and add them all together. Okay, so let's start with this first one. Okay, this is 8.3. So I need to add the probabilities of red and red plus the probability of green and green plus the probability of yellow and yellow. Okay, so the probability of red and red, let's see, 6 over 32 times 5 over 31. Okay, so 6 over 32 times 5 over 31 plus the probability of green is now 8 over 32 times 7 over 31. Okay, so 8 over 32 times 7 over 31. Okay, and the way I'm getting these values is just by following the branches, right? So here's red and red, so I took these two. Okay, let's look for green and green. I took this branch, that branch, and I just multiplied those two together. Okay, now for the yellow one, I'm going to take that branch and that branch. So it's that and that. Okay. So 18 over 32 times 17 over 31. Okay. Now I'm just going to put all this into a calculator and see what we get. Okay. So 6 over 32 times 5 over 31 plus 8 over 32 times 7 over 31 plus 18 over 32 times 17 over 31, and that gives us 49 over 124. So 49 over 124. Okay, so that's the right answer for that.